Hola amigos and welcome to the Tamer Show. I'm going to show you guys how to do the spatial pattern, and the spatial pattern is a breakdown into smaller components when working with enemy soldiers and you want to detect what enemy soldier is the closest to you. So normally how we would go around this is we would actually go straight into making a list of all the enemy soldiers and then iterating through that list every time we want to see what enemy is closest to us. And I think this is really inefficient and not the best way to do it. This is why we would incorporate the spatial pattern. And what the spatial pattern actually does is on that ground platform that the enemy is on, we're going to divide the platform into individual cells and then associate each cell with an enemy. So instead of having to iterate through a whole list for every enemy in the game, we're just going to associate an enemy with a cell within the platform that the enemy is currently on alongside all of his partners. Okay? And how we're going to do that is through the spatial pattern. Okay, guys, let's get ready. We're going to have some fun. So, first things first, we're going to initialize all the objects and materials that we're going to use to make this. And before we get started, I want to show you guys how it looks. So, when I run it, you can see that the blue are the friendlies and the red are the enemies, and you can see that each blue friendly is staying within its own cell, and it's not going to chase an enemy outside of its cell. It can only detect an enemy once it reaches its cell, simply because each friendly is associated with the cell. And then once an enemy enters a cell, it enters an object where that friendly is associated to as well, where it can detect and now see what enemy is closest to it, making this process a lot more efficient and effective. Okay, guys, so to replicate this, all you guys want to do is make a red material and a blue material. You can also make a yellow material. I added that because I wasn't able to get it to work, but initially what was supposed to happen is the closest enemy to you would become yellow, but right now it's not doing that. We're going to go ahead and skip that part though. I'll also add the source code into the description of this video where you guys can take a further look to the code. Okay guys, let's go ahead and continue. So what you're going to want to do is make two materials, a red material and a blue material. You're going to want to go ahead and initialize a prefab by going here and doing create and then select prefab. Once the prefab opens, click into the prefab, and then you're gonna want to create a sphere. So you're going to go into create 3D object and then select sphere. I accidentally created a game object. Okay, once you create that sphere, drag your red material onto the sphere to make your enemy red. Same thing with the friendly. You're gonna make a friendly prefab and then go in here and then make a square and then put the blue material on top of there. And then what you're going to want to do is create two empty objects for the enemy and the friendly parents. So you're going to come in here and then create an empty object. And then once you create two empty objects called enemy soldiers and friendly soldiers, you're going to simply drag the friendly inside the friendly, and then you're going to drag the enemy inside the enemy. Okay. So once we have those steps done, we're going to go ahead and make a plane for the ground. And how to do that is you're going to come here, create 3D, and then select plane. Once you select plane, name it ground, position it to 25, 0, 25, and then for the scale, you're going to do 5, 1, 5. Okay, and once we're here, you're almost done with all the object creation on the console. You're just going to want to do one more thing, and what you're going to want to do is make a game controller. And this is how we're going to be able to control our game. Kind of like the MVC pattern that we learned previously. And totally forget this. This is like a error that I just ran into. You don't need this right now. Okay. So we're going to go ahead and now talk about the scripts that we need to make this working. And we have about 5 different scripts. We have the soldier script, we have the grid script, we have the game controller script, the friendly script, and the enemy script. Okay. So I wanted to let you guys know that the soldier script will be the super class for the enemy script and the friendly script. The game controller controls everything, and the grid is the grid. The game controller will also spawn your friendly and enemy objects, so you don't have to worry about putting them on the map. The game controller will do that by itself. And I think it only makes sense to start off explaining what the game controller does. So we're going to go ahead and jump right into that. So open up and develop a new script called the game controller script. Once you make the game controller script, make sure you make the namespace called SpatialPattern. You're going to want to initialize 3 different lists for the enemy soldiers, friendly soldiers, closest enemies. You're going to want to make the properties for the grid. So you're going to make cell size equal to 10, map width equals to 50. Initialize the materials, and then initialize the friendly object and the enemy object. Make the initialization for how we want to iterate through the array for the number of soldiers, and then the grid. Then we're going to use this to make the new grid. And then this is how we're going to iterate to add all the random enemies and friendlies and put them into a list. We're using vector 3. We're using the vector 3 class to position the enemy onto the cell. And then we're going to instantiate the enemy with this random position, and then we're going to put that into the enemy soldiers list. And we're going to do the same exact thing we did for the enemy inside as well with the new friendly. We're going to come down here to the update. And in the update, we're using this for loop to move the enemy. And we'll see more about this move function later when we enter the actual enemy soldier script. And what this for loop is doing is resetting the material of the closest enemies, and we're clearing it. And then down here in this for loop, what we're doing is for each friendly, we're finding the closest enemy and then changing its color, and then we're chasing it. Okay. And this is the fast version with spatial. And down here, as you will see if you use the source code, this is the slow version of how you would do it. Is you would iterate through the whole enemy count, but instead this is the fast version. Okay. And then basically you would move the friendly in the direction of the enemy, and then up here you would change the material. Okay. So this is the game controller, guys, and don't worry, this will be inside the source code. Okay, we're going to go ahead and now quickly talk about the grid. So open it up. Make sure you create a script called grid. Open it up. Make the namespace spatial partition pattern. And then what you're going to do is basically what this is going to do is going to convert from the world coordinate position to the cell position. And then what this is doing, this is the actual grid where a soldier is in each cell. So each individual soldier is linked to another soldier in the same cell. What this is doing, this is initializing the grid. And then right here, we're basically adding units to the grid. And then we're associating each cell with a specific soldier. And then here we're just adding the soldier to the front of the list. And then this is how we're determining cell X and cell Z. This is how we're determining what cell the soldier is actually on. Then down here in the find this closest enemy, what we're going to do in this one is we're going to get the closest enemy from the grid, and then same thing is up there. What we're going to do is here is we're going to determine what grid cell the friendly soldier is on, and then down here we're going to get the first enemy in the grid, and then we're going to find the closest enemy of all the soldiers in the linked list. And we're going to loop through the linked list, and then we're going to use the area to determine the distance between the enemy and the soldier. And then we're going to say, if this distance is better than the previous distance, make this the new closest enemy soldier, and then we're going to return it. And then this is the move function that I was talking about earlier. If the soldier in the grid has moved, see if we need to update the grid for the soldier. And then we're going to same thing, see what cell the soldier is on, and then see what cell the soldier is currently in now. If it didn't change at all, then we're done and return. But if it did change, unlink it from the list and from its old cell. Then add the soldier. Okay. Now, what I want to do is I want to dive into the superclass first before we get into the subclasses. So I'm going to go into soldier and then just show you guys what's happening in here before we go into its subclasses. So once again, you're going to make a namespace called SpatialPattern. Call the script soldier, and then you're going to initialize the mesh renderer, the soldier mesh renderer. You're going to make the previous soldier and then the next soldier, and then the move function and the move function, and then its subclasses are going to inherit from here. Okay. And then we're going to go ahead and friendly, and then I'll give you guys a brief overview of what this script is doing. So for this one, make sure that you have your namespace, a spatial pattern. What you're going to want to do is initialize friendly, the walk speed to 2f, and then soldier trans equals soldier object dot transform. And then for the move function down here, this is going to do, it's going to move your friendly soldier towards the closest enemy within the grid. And then this code focuses on rotating and moving the friendly towards the enemy. Okay. And then let's go back here, and then make sure for the enemy script, you make a new enemy script, add it to the console, open it up, and make another namespace called SpatialPattern for this one as well. And then you're going to want to initialize a grid, a float map with vector 3 old position, and a vector 3 current target. The vector 3 current target is the position the position the soldier is currently heading for when moving. And then the vector 3 old position is the position the soldier had before it moved. Okay. So we can see if the soldier actually switched positions. This is the function where we're going to initialize the enemy class. And this is basically how we're going to see what we need to save, and then we're going to add the unit to the grid. We're going to initialize the old position, and then we're going to give it a random coordinate to move towards. And here we're going to inherit the move function from our superclass soldier. And what we're going to do with this is we're going to move towards our target with this code up here. And then what we're going to do is see if the cube has moved to another cell, save the old position, and if the soldier has reached his new target, find a new target. Pretty cool, huh? And then for the last function of this class, or of this script, what we're going to want to do is get the new target. We're going to give an enemy a new target to move towards, and then rotate towards that target. Hey guys, so now that we're here in the console, let's just not make sure that we forget to add the mesh renderer to the enemy and also add a mesh renderer to the friendly, just so the friendly can detect the enemy. If you don't add these, you'll probably not see the friendlies chasing the enemies once you run it. And also come here to the game controller and you want to drag the enemy soldiers and the parent of the friendlies into the parents here, and then drag the materials into the materials, and then drag the prefab of friendly and enemy into the friendly and enemy objects here. Then once you do that, everything should work perfect. We're going to go ahead and hit play. And as you can see, our friendlies are chasing our enemies. Isn't that cool? I'm going to come here for a better view into this, and we're going to be able to see that our friendlies are not exiting their cells. For example, these friendlies are staying still because no enemy has entered their cell. And now, as you can see, as soon as an enemy enters their cell, they chase them. But once they leave, they're not worried about them. And what this does is it lets us efficiently and effectively use our memory processing to better efficiently use our enemies and our friendlies. So we don't have to iterate through a whole array, but instead focus on smaller componentized objects and only have friendlies worrying about what's in their cell and not what's in other people's cell. Hey guys, so I hope you guys really enjoyed this tutorial. This was really awesome learning. And I want to give a quick shout out to Hybrider for his tutorial on how to do the spatial pattern. It was really awesome. I'll drop a link to his page and his blog down below in the description. And by the way, like I mentioned earlier, I'll also add the source code to the description as well. I hope you guys enjoyed following along on how I did the spatial pattern. Hope you guys have a great day. See you guys later in the next one. Thank you guys.